In this video, I will go through the section 11.4 of chapter 11 of applied maths, which is using integration. Okay, so in previous lesson, we learned that to get from displacement to velocity, all we need to do is just differentiate the formula for displacement to get the velocity. And to get from velocity to acceleration, we need to differentiate the formula for velocity, okay, to get to acceleration, in variable acceleration, obviously. Okay, so in this video, we're going to learn opposite of that. So imagine the formula for acceleration is given, and we've been asked to work out the velocity at certain time. So all we need to do, integrate acceleration, okay, get to velocity. Or if you've been asked to find displacement, all you need to do, integrate acceleration twice to get displacement, or integrate velocity once to get in acceleration. Okay, so let's go through the example 6 from the textbook. A particle is moving on the x-axis. At time t second, t equal to 0, the particle is at the point where x is equal to 0, x equal to 5. So therefore, when t is equal to 0, x is equal to 5. Displacement is equal to 5. The velocity of the particle at the time t seconds, where t is greater or equal to 0, which must be greater or equal to 0 because time should be always positive, is, so the formula for velocity is given, which is 6t minus t squared meter per second. Find an expression for the displacement of the particle from O. To find the formula for displacement, all we need to do is just integrate the velocity. So S is equal to integration of velocity with respect to time. Therefore, S is equal to integration of 6t minus t squared with respect to time. Okay, now we should know this from the pure maths. Integration of 6t with respect to t is 6 over 2t squared minus 1 over 3 t cubed. Don't forget plus c. Okay, where c is a constant. Okay, so let's simplify. Therefore, S is equal to displacement is equal to 3t squared minus 1/3 of t cubed add c. We know that in this case S is equal to x. We should clarify that S is equal to x because it says it moves on x-axis, so therefore I should label x or s. Okay. However, I didn't really need to write s here. I could just use x. Okay. To find c, all we need to do, it says when t is equal to 0, x equal to 5. Therefore, 5 equal to 3 times 0 squared minus 1 over 3, okay, 0 cubed plus c. Therefore, c is equal to 5. And finally, x or s is equal to 3t squared minus 1 over 3 t cubed plus 5. Okay, which is the answer for part A. For part B, it says the distance of the particle from its starting point when t is equal to 6. Okay, to find the distance of the particle when t equal to 6, okay, so we can use the result from part A, which is x is equal to 3t squared minus 1 over 3 t cubed plus 6 plus 5. Okay, so when t is equal to 6, okay, x is equal to 3 times 6 squared minus 1 over 3, 6 to the power of 3 plus 5. Okay, so x is equal to 41. The distance from the starting point, the distance from, it doesn't say the distance from O, it says the distance from a starting point. Where originally the particle started from 5 meters away from the origin. So, therefore, the distance from the starting point is 41 minus, it was already 5 meters away from the origin, okay, which is 36 meters. However, this formula, it just gives you the distance from the origin, not the distance from the starting point. To find the distance from the starting point, you need to take away where the particle originally started from. Okay, so end of the exercise, example 6. Okay, let's move on to example 7 now. Example 7. A particle travels in a straight line. Okay, after t seconds, its velocity v meter per second is given by v equal to, okay, let's write down the solution. V equals to 5 minus 3 t squared, where t is greater or equal to 0. Find the distance traveled by the particle in the third second of its motion. Okay, so we need to find the distance traveled in third second. Okay, what we need to do here is, it is always easy and convenient, okay, to sketch the diagram for this. Okay, let's say here is the v-axis and here is the t-axis. Whenever you need to integrate, it's easy to sketch the diagram, but when you need to differentiate, so you don't really have to. Okay, v, and we know that first of all, let's find out the root, okay, of the equation. 5 minus 3t squared is equal to 0. Okay, 3t squared is equal to 5. T is equal to plus or minus root 5 over root 3. Okay, so, and the graph would be N shape, obviously. Gonna to cut the y-axis or v-axis at 0.5. Let's say here is 5. Okay, so it will be something like this. Okay, and it would obviously continue and cut the diagram in negative part here, but we are not really interested in negative part because time cannot be negative. Okay, so it says, the question says, by the particle in the third second of its motion. Third second, it means from time t equals to 2, let's say it is here, up to t equal to 3, let's say here. So, which means we want to work out this area. Okay, let's highlight it. To work out this area, all I need to do, this is the formula for velocity. Okay, v equals to 5 minus 3 t squared. To find this region, all I need to do, okay, so s or x equals to integration of 5 minus 3 t squared with respect to t from 2 to 3. Okay, so therefore s is equals to Integration of 5 is 5t minus 3t squared is t cubed from 2 to 3. Okay, let's sub the values in. 5 times 3 is 15. 3 squared is 27 minus 5 times 2 is 10 minus 8, which is minus 12 minus 2, which is minus 14. Since it is, you should know from pure maths, okay, since the area is below the x-axis, in this case t-axis, it is negative. However, distance cannot be negative. So distance traveled, when it says 30 seconds, it means t between 2 and 3 is 14 meters. Okay, so this is the end of the chapter 1.4. Okay, and you will be able to do exercise 11D after watching this video, which is, if I'm right, it should be page 188. Okay, 189, 189, 190, and 191. Exercise 11